Let's get started talking about tools right away and the tools that you're going to be needing in order to get this job done. First things that you're going to need to have is you're going to need to have some type of an adapter to turn the engine over. There are lots of different adapters that have been designed for specific models of cursor engines. You need to find the one that best fits the application that you have. For this application we have here today, we're going to use this adapter. This works real well. It goes in the starter hole. It has interchangeable pinions for it to mesh with different flywheel drive gear configurations. So we're going to use this one. The next thing that we're going to need in order to do cursor timing is we're going to need the timing pin and the phonic wheel alignment tool. Both of these are critical elements in order to pin the flywheel and to time the unit correctly. Third thing that we're going to need is we're going to need a dial indicator. A good quality dial indicator is definitely required, and you need to make sure that you have enough travel in here to accommodate at least 10 millimeters of travel. A good strong magnetic base helps to keep the dial indicator in position as you're taking the measurements off of the rocker arm for the timing procedure itself. Digital versus analog, your call, your choice. However, you do need to remember that during this process, we need to actually set a zero value and then go back from there for our actual lift measurement on the camshaft. So having a digital dial indicator helps do this much easier than an analog one and a lot of math. So our next thing that we need to have is we need to have some specifications. Your specifications for the individual unit and the camshaft lift specifications are found in ETIM, and again, are models dependent for the unit that you're working on. You need to make sure that you get the specifications for the engine that you are working on. We have the specifications for the unit that this engine is out of here, and we'll be using those today. These are not universal specs. You need to make sure that you get the correct specifications from ETIM before you start out, and don't rely on what we do here in this video as the specs you should set it for. With all of that, I'm going to get things installed here. We're going to move over to the engine and we'll start talking about things over there. Cursor engines have been around for several years in lots of different models available through CNH Industrial and also in a non-captive market here in North America. Today we're going to focus on some of the differences between these two models, and then of course we've got individual videos on how to actually perform cursor timing on both of these. The older unit injected style that we have here and the newer common rail cursor engine here that's available Tier 4 final and was available in twin stage as a Tier 4 interim model. A couple of things to point out here on the back sides of the cursor that become important right away to understand is that both of these models that we're looking at here are full bell housing cursors. There is a partial bell housing cursor that has been available for several years in many different models. And of course the partial bell housing is essentially missing the bottom half of this bell housing cover. It makes our timing procedures different for those models. Today we're going to focus on the full bell housing ones, but briefly to bring you up to speed, whenever you're timing a partial bell housing cursor, you need to remember that all of the timing is done through the hole for the crankshaft speed sensor. The lining up for the alignment and the pin placement to lock the flywheel. On these full bell housing units, the locking the flywheel is done through the crankshaft speed sensor, and the marks are read through the spy hole in the bottom of the bell housing. So again, you have to determine right away what cursor model that you're working on, what type, full or partial bell housing, and then of course you need to know if you've got a unit injected engine or you've got a common rail engine like we have here. All right, so let's get acquainted a little bit with the back end of this unit injected cursor engine. On the back side of it, we have our camshaft. We have our series of holes that fasten the gear on. We also have an individual marking hole that's here on the back side of it. A lot of instructions that have been published previously show that hole in a specific orientation. It's very difficult due to the different configurations of camshafts. We've discovered that hole can move around. Therefore, using the holes that you find on the back side of the camshaft are not good choices for determining if the camshaft is in the proper position to start timing. We'd rather see you use the front holes, and here we have a shot of the front holes on the camshaft in its proper orientation. Here are 3 holes for cam timing on this particular camshaft. We have 2 threaded holes here on either side, and a dowel hole with no thread in it here up at the top. You do need to be aware that different cams have come out for different model engines that have different configurations of these holes. The one thing that they do have in common with all of the installations is this dowel hole with no threads on it goes up here at the 12 o'clock position. You may find one with a hole over here and no hole on this side, or you may find the opposite where you have a hole over here at the 3 o'clock position and one again at 12. But what was the common theme? The hole with no threads, the dowel hole at 12 o'clock. That's proper installation for the camshaft to have the engine at number 1 TDC. Moving down to the flywheel, we're going to move down to the flywheel area now, and we're going to talk about what's going on down here. If we look at our diagram over here in the A position, we have cylinders 3 and 4. Down here at B, we have 1 and 6. And of course, up here at the C position, we have 2 and 5. Our D mark is 54 degrees before top dead center on cylinder number 1. Now, of course, all of this indicates that the engine rotates in a counterclockwise fashion. We're going to take a minute and we're going to draw on here that this is actually going to rotate in that fashion. You need to make sure when you're interpreting instructions that you understand where you are standing and the relationship of the turning of the flywheel. We've gone to great lengths in a lot of the materials that we've published and put together to make sure that you understand that it's the flywheel direction of rotation as standing here viewing it from the back. Well, we're going to mark the direction of rotation here, and of course the engine rotates in a counterclockwise, as viewed from the rear, fashion. Now that we understand what's going on with the flywheel, we understand what's going on with the camshaft. The next thing that we need to be concerned ourselves with is where do we need to put our dial indicator to take our measurement from. Unlike the newer model cursors with common rail, this unit injected model, you install the dial indicator on the number 1 injector. So instead of putting it on one of the cylinder exhaust valve rockers, it goes on the injector for the number 1 cylinder, making this system a little bit more unique than the common rail. So now we're going to install our dial indicator. It's important with the dial indicator to make sure that you have enough preload travel in this. I always like to preload these to around 10 millimeters. There are a lot of different specifications out there that say 7, 8, whatever. 10 for me, it's a nice round number. I have never seen one that needed to be preloaded more than 10. If you don't preload the dial indicator enough, you'll run out of travel during the timing process. So as a result, we always want to make sure that we have more than enough and not too much more. Again, it is preload, so it is not an exact, right on the money 10 millimeter amount. So let's get this positioned in here, and we'll turn on our magnetic base and lock it down to the engine. Things to be mindful of when you install the dial indicator is that you have to remember that both the intake and exhaust as well as the injector rocker all move. So wherever you put this, you do need to make sure that as these valves are actuating, as we're turning the engine over, it doesn't disturb the base, which would change and alter your measurement. So we'll take a look here. We're up over 11. We need to make sure that our indicator rod is at 90 degrees. Right now I see it leaning back a little bit. So we're going to straighten that up and to get it centered. Straight up and down here, and then of course we want to look longitudinally down the engine to see that this is actually in the center line of the roller. It's very important to make sure that this is in the correct position and it's not on an angle pushing in and out. It'll cause inaccurate readings and cause your timing to be off for your camshaft and your engine. So with that said, where'd we end up? About 10.6. That's okay. I've got my 10 millimeters and a little bit more, so we're ready to go on to the next step. As we get ready to move on, we need to install our camshaft gear on our camshaft. We do have our cam in the correct orientation. We've got our number 6 rockers in valve overlap, meaning our number 1 cylinder is in compression stroke and at top dead center. Based on our position from our crankshaft, we've got our dial indicator installed. Let's get our gear on here in the correct orientation. Again, these gears need to be installed so the center, the bolt hole is fairly centered in the slot. This allows adjustment both ways, so we get our correct, so we can adjust, make our cam adjustment to get our correct lift adjustment on the camshaft. So with the gear installed, let's throw some bolts in. We're going to tighten the bolts down. We don't need to torque them up to full torque right now. With our bolts tightened down, we can now turn the camshaft with the crankshaft gear. As we go around, we now need to find base circle and get the dial indicator adjusted to 0. So we're going to turn the engine clockwise in order to achieve that. Now remember, our direction of rotation is counterclockwise. We need to go backwards to get to before the timing event for top dead center. We rotate in a clockwise rotation. Our dial indicator has stopped moving, indicating that we are at base circle. Now we zero our dial indicator and we're ready to go. And we want to turn the engine in the direction of rotation, counterclockwise, until the 1 and 6 mark are pointed down and we can install the pin in our crankshaft speed sensor hole. So we're going to turn the engine here. As we get close here, we need to take our timing pin tool in our speed sensor hole. Once this is lined up and we have lined up our marks, we've installed this. Based on our specifications, we should have 4.44 millimeters of lift on the camshaft. We see we're reading 5.44. We have 1 millimeter too much lift on the injector for this particular application. So we're going to need to adjust the camshaft in order to get the correct amount of lift. To do that, we need to readjust the camshaft so the lift is correct, and then we'll have to reposition the crankshaft in another step. So, doing this, take our flywheel lock pin back out again. We're going to rotate our engine backwards again in a clockwise fashion. We're going to want to make sure that we go well past our minimum amount because we want to ensure that we have all of the backlash out of our gear train. We're going back again in a counterclockwise rotation, back towards the 1 and 6 mark, And instead of watching for our 1 and 6 mark to put our pin in, we're watching the dial indicator to get our lift correct. So 4.44 is where we want to be. Okay, so there's our correct lift specification. Now our lift specs are plus or minus 0.05 millimeters. Here's a trick for you. We timed quite a few of these. What usually ends up happening is when we do all of these adjustments, there's backlash that we pick up in this gear train. It does throw this timing off a little bit, and it does add that backlash in. What we want to do to help make you a little bit more successful and make sure that you fall into that 0.05 millimeter range is we're going to overshoot that by about 0.03 or 4. All right, so we're now 4.48. If we look back down at the flywheel, we notice our flywheel is nowhere near in the correct position, but the camshaft is. At this point, we want to loosen our bolts up here on the camshaft and allow the gear train to be readjusted so our number 1 on our crankshaft can be put at 1 and 6. The camshaft will stay in this position as long as nothing happens to it and while we're doing this process. So let's loosen up our bolts here. This is why we have that slot in the gear. So now we're going to very slowly turn the crankshaft. Again, since we're turning it in the direction of rotation, we don't have to worry so much about the camshaft. We don't have to worry about backlash problems. Now that we're pinned at 1 and 6, our camshaft is still the same. We're going to tighten our bolts back down. We're not going to torque them right at this point because we're going to want to test to make sure that what we've adjusted is correct. Take our lock pin out. We want to run our engine clockwise. Again, we want to make sure we have all of our backlash correct on the gear train when we come up for our measurement. Get ready to insert our pin again as we come around to 1 and 6 at TDC. Our pin's in, and we came up with 0.439. 0.444 was our spec. This is actually at the bottom end of the specification. Remember, if we wouldn't have added those extra few hundredths of a millimeter here, we would be short right now. We could have added a little bit more. With this all adjusted correctly, we're within our timing range. We can move on and torque our bolts here. And again, these are torque angle bolts, so we want to make sure we use our torque angle adapter on here as well as set our preload. These torque angles are set at 60 degrees, and although you may be able to do 45 or 90 or 180, 60 degrees is a little bit tougher. Start using torque angle wrenches, torque angle gauges on these engines, guys. It's very important to get the proper torque on these fasteners. All right, now it's time to get ready, and we're going to install the phonic wheel. The phonic wheel is done for the injector timing. We've got our tooth marked on here for our phonic wheel. This meshes with our phonic wheel adapter positioning tool that goes in through the camshaft speed sensor hole and aligns this phonic wheel. You notice the phonic wheel is slotted, so it fits on here. And of course, our speed sensor is over here. We're just going to get this fastened in place here really loosely at the moment. We do have a bit of a problem because, we don't have our crankshaft in the correct location. So let's just put this up here for a minute, and then we have to put the crankshaft to our 54 degrees before top dead center and pin it there. So we're just going to set this in here right now. This is still loose, and set that here out of the way. We need to come down here to the crankshaft. We need to take our pin out. We need to go back to 54 degrees. Now, of course, you got to remember, if I just turn this back to 54 degrees, all my backlash is in the wrong place on my gear train. And this unit will not be in time if you just stop here and do this. You need to make sure that you go back far enough, again, in the wrong direction here, and then turn around and load the gear train up correctly and come back up to our 54 degrees. And once we get there, as we begin to approach, we need to put our pin back in here for the crankshaft and pin those two holes in that spy hole down at the bottom of the engine. There we go. 54 degrees before top dead center. This is the position that we adjust our phonic wheel in. Remember how we weren't in the right place before? Look at that. Magically fixed. Tighten these fasteners down, and then we need to make sure that we torque these to the proper torque. It is a good idea to put some 243 Loctite on these in order to keep them from coming loose. We're not putting any on here at the training center today because we take this apart and put it back together and time this engine quite frequently in all of our in our engine diagnostic classes. So as we finish torquing these all up, this proper specification, we're really wrapping this job up. We've verified that our timing lift is correct. We've got our phonic wheel installed in the right place. We're going to take our engine pins out. And of course, as the last step, one of the things that you guys always want to make sure that you do is to turn the engine over at least 2 full revolutions by hand to make sure that everything is in fact timed correctly and the engine does rotate over 2 full revolutions. Thank you very much for watching the video today. Happy timing.